Okay, hello everyone, and good afternoon or good morning, depending upon what side of the world you're on.
Yeah.
My name is Eric Camuli, and I am the Customer Success Officer here at 7SIGNAL. And I am joined by my esteemed colleague, Miss Erica Ironman. Say hello, Erica.
Thank you very much, Eric. Hello, everyone. Thank you so much for taking the time to be on this webinar with us today. We're very excited to have you here.
That's right, we are. And what we're going to be doing is just touching, if you will, on 7SIGNAL, and really then spending all the rest of the time that we have together giving you some basic principles about how Wi-Fi works, and just basically making sure that we're all on the same page when it comes to certain things like interference, coverage, congestion. What do these things mean? Let's all get on the same page. Let's review it together as a team, and then when we leave environments back to our own coworkers and actually either understand what they're talking about, or with our newfound knowledge, be able to be somewhat of a subject matter expert with regards to these principles. So the point is that Wi-Fi, it's not a mystery. Now, to many people it is because they can't see it. You can't see Wi-Fi, you can't touch it, you can't feel it. And so it's a little bit of a mystery to a lot of people. Erica, I'm here to tell you, it doesn't have to be.
Awesome.
Yes. Now, before we go any further, Erica, I did want you to just go over who 7SIGNAL is and what we offer people, and then I'll take it on back and we'll talk about those Wi-Fi 101 principles. So, Erica, you've been with us for probably 6 to 9 months now. You're learning a lot about 7SIGNAL. I hope it's been a good experience so far.
It's been awesome.
Super. And what we'll do is just have you tell a little bit about us. Go ahead.
Perfect. So,
sitting here at the office. What's going on?
Go ahead and take it away.
Okay, perfect. So we were originally founded back in Helsinki, Finland, back in 2007 by some Nokia engineers. Did eventually relocate to the Cleveland, Ohio area. That's where our current headquarters is today. In 2012, they wanted to tap into the abundance of wireless knowledge that we had in this area. So that's how we ended up here. We're also certified in over 40 different countries, and we monitor over 4 million global Wi-Fi devices daily. And that number continues to grow as we continue to add on more customers each day.
You know what? And Erica, I wanted to provide a little bit of color on that abundance of Wi-Fi talent in Northeast Ohio. A lot of people consider Akron, Ohio to be one of the birthplaces of Wi-Fi, and here's why. A long time ago, there was a company called Telzon. And Telzon, this goes back many, many years. They were one of the first use cases for Wi-Fi were those scanners that at the car rental place where they print out your receipt right there on the spot and give you a receipt when you get out of your car. That was the first use case for Wi-Fi. Telzon worked on that technology. Telzon was eventually acquired by a company you may have heard of called Symbol Technologies, which is in all sorts of scanners all around the world. The other Wi-Fi, tie back to this part of the country is where Aeronet was founded. Aeronet was acquired by Cisco in, I think it was 1999, year 2000. And so there is just tons of Wi-Fi expertise in this area, and we're really excited because we've been able to benefit from it. Pretty awesome.
That's awesome.
Now, Erica, why don't you tell us a little bit about our modules before we go any further? Go ahead.
Yeah, diving into our 2 modules that we provide here at 7SIGNAL. On the right hand of your screen, you're going to see our first module, which is called our Sapphire Eye. Now, this is going to look similar to an access point, and this Sapphire Eye is installed into your wireless environment. So in like a hospital in the ceiling, and that's where you'll be able to find this device that we provide. The Sapphire Eye is a 802.11 AC client. Now it's going to run active tests such as throughput, packet loss, latency, and jitter. Also going to give you your MOS score. It's also going to give you passive tests like airtime utilization and channel utilization as well. So it is a really robust tool for your wireless team to utilize in your environment. And then looking over at our second module, we have our Mobile Eye. So this is a background app or service that's going to run on your laptops, tablets, phones. It's compatible with Windows, Mac OS, Android. And similar to Sapphire, it's going to give you those active tests, your throughput, packet loss, latency, give you some passive tests as well, such as SSID and BSSID. But the most important part about this module is it's going to give you the adapter make, model, and driver version of each of the devices that this module is monitoring. So that's what makes this tool very unique as well.
Yeah, it's really special. You know, when we talk to our customers, Erica, you know this, they'll tell us that probably half of their problems trace back to clients. And so we're actually pushing our solution all the way to the edge of the network. We put Mobileye on the devices, and we can see all of the connection information. We can see the wireless experience from that device's point of view. It's remarkable. And then for the other half of the problems, you know, what's going on in the air, what's going on with the back-end network, we've got Sapphire Eye. So we've got, you can use one solution, you can use the other, or you can use them both together. And, you know, you log into the cloud system and you do that.
Right.
All right, let's jump right into it, guys. Enough of that product stuff. Let's talk about Wi-Fi. So here we go. What's important for you guys to note first and foremost is that we're talking about bands of air that we call the spectrum. And what you need to know also is that there is licensed and unlicensed bands of air or spectrum. Licensed means that you've got to pay the government in order to use it. And if you are operating on those frequencies and you shouldn't be, then you can get fined by the FCC, for instance. Then there's unlicensed, and unlicensed is just like it sounds. It's free. It's free for anybody to use, and those are these right here that you probably recognize. And Wi-Fi operates over these two bands of spectrum, 2.4 and 5, and we're going to talk a lot about them today. And when we do, basically you're going to, you know, learn the differences, and it should be really important. But what I really want to impress upon you is that it is a band of air that is finite. You have to operate, you know, from the low point to the high point. You are not allowed to operate outside of it. Again, then you're into licensed spectrum and you're not allowed to be there. All right. And so think of it as like the highway. And when you're traveling on the highway, when you're driving down the road, you're not allowed to drive on the median and you're not allowed to drive on the shoulder. Erica, you ever see those people who are trying to get ahead and they drive on the shoulder?
Oh yeah, and that's so annoying.
It is. It's actually inappropriate and somewhat obnoxious. And you're not allowed to do it. And if a police was close by, they'd ticket that person. You got to stay on the road. You got to stay on the road. Okay, so that's really important. And not only that, but there's only so many lanes on the highway, right? And so that's the analogy that we use here when we're talking about the important principle of capacity. Capacity are like these lanes on the highway. We have channels in the band, just like we have lanes in the highway. All right, and as you can see here, there's just a few lanes, and you've got all of these cars, and they're stacked up, and you know, there's only so many lanes for them to operate in. And if you don't have the only way to alleviate this congestion right here is less cars or more lanes. And so it could be really frustrating when you're sitting in traffic, you know, just like when we commute to work every day. Now, one of the things that you notice here is that there's a perfectly good lane that is not being used right here. Do you know what that lane is, Erica?
Is that the carpool lane?
It is the carpool lane, or called the diamond lane, or sometimes the HOV, high occupancy vehicle lane.
Oh, wow.
Indeed. And so as you can see here, it is not being used at all. This is a very inefficient use of the highway. And you could be doing the same exact thing with regards to an inefficient use of the spectrum. If you don't have a good channel plan, if you're not using the channels that are available to you properly, then you can have situations like this where everybody's crammed into these two lanes right here. You have a perfectly good one right here that nobody is using because you haven't provisioned it properly. So we're going to learn a little bit about that in our next slide. Okay. Now I did see, if you do have questions, then what I'd like to invite you to do is use your control panel to actually pose those questions. And then what we'll do is we'll have a little bit of time at the end and we'll actually answer those questions for you. So I just wanted to make that important note. All right, let's move on and talk more about channels in the band or lanes in the highway. So here we go. The important principle here is capacity. The 2.4 megahertz or gigahertz band only has 3 non-overlapping usable channels for Wi-Fi. Now, of course, there's channels 2, 4, or 2, 3, 4, and 5, but those would be overlapping. And overlapping is bad in Wi-Fi. Do you know why, Erica?
No, I don't.
Overlapping is bad because overlapping will cause these collisions in the air. And when you have collisions, collisions lead to retries. Not good to get into a collision on the highway, is it?
No. Oh, no.
Not at all. And what happens when there's a collision on the highway? It slows everybody down.
Right.
It's almost the same thing in Wi-Fi. When there's a lot of collisions in the air, then there's a lot of retries that take place. And when there's a lot of retries, that means that everybody's got to slow down their data rate in order to cut through what's happening. So we want to stay on 1, 6, and 11 non-overlapping channels. And you would use 7SIGNAL in order to see all of the radios in your environment and what channels they're on, in order to make sure that you are following this very important principle. Now, the other thing to note is that there's only 3. And when you look at 5 gigahertz on the bottom of the slide here, we're talking about over 20 non-overlapping channels. There is major capacity here. That's basically going from a 3-lane highway to a 20-lane highway.
Oh my gosh.
Yeah, so it is really, really remarkable. And so, I mean, when you have a 20-lane highway, everybody can spread out, everybody can go fast. There is a lot less congestion, and that's why we're trying to move our customers more and more to using 5 gigahertz, because there's just so much capacity and a lot less congestion and aggravation. Now, there is something that you can do in 5 gigahertz, which is kind of cool, and that is channel bonding. You can bond 2 channels together in order to create kind of like a super channel. We call it HT40, which stands for high throughput 40 megahertz wide. So think of this as like a super lane on the highway that you can go really fast in, extra fast. As a matter of fact, doubly fast.
Oh my goodness.
Yeah, exactly. Now, and you can also do the same thing over here on the right. This is VHT80, which stands for, any ideas?
I'm stumped.
Very high throughput. Yes, I know, it's really sophisticated here.
Yeah.
Very high throughput, 80 megahertz wide, where we've bonded 4 channels together in order to create a mega channel right here. Now, what I will tell you is this: sometimes this is a good idea, and sometimes this is a terrible idea.
Right.
All right, because what happens here, Erica, is that when you bond these channels together, you are now cutting down on the overall number of channels that are available to your customers or to your users.
Mm-hmm.
It's like putting up orange barrels, and now instead of having 3 lanes on the highway, I've only got 1. All right, and that bottleneck creates all sorts of congestion, doesn't it? So you got to be careful. If you have an environment where there's tons and tons of people, tons and tons of users, you need to be careful about your use of 40 megahertz wide and 80 megahertz wide channels. It may be better that you have more channels that don't go quite as fast. All right, if everybody can share a lot of these channels, it would be a lot better for your environment. Not only that, but you know what? Even though you have HT40 and even though you've got VHT80, it's very possible, Erica, that your laptop computer, the one that I'm looking at right now, might not even be capable of taking advantage of those super high speeds. Did you know that?
No, I had no idea.
Exactly. We're going to talk about the capabilities of your laptop computer in just a second.
Awesome.
All right, but the point here is that you've got computers, you've got devices out there that aren't even, it's like trying to drive an old jalopy, versus trying to drive an Audi S5. You know, it's just a total difference in what kind of vehicle you have. It's going to be dependent upon how fast you can go. So that's really important to note right here. We're talking about capacity. There is very little capacity on 2.4. It's a free band of air. Everybody's using it. There's only 3 lanes on the highway. It gets really crowded. Do not use, it's even worse if you're using channels 2, 3, 4, and 5, 7, 8, 9, and 10, because they're overlapping, and that's going to cause collisions. Collisions lead to backups. Retries are no good. It leads to going slow. Just think about the highway analogy, right?
Right.
All right, so we want to get people to 5 gigahertz. Now, what is a way that you can get people to 5 gigahertz? Well, there's this concept that we called band steering. And that's exactly what we're doing. We're trying to steer people from 2.4 to 5, because we know if they're on 5, they are highly likely to have a better Wi-Fi experience. They are more inclined or more likely to go fast if they're on 5 gigahertz. So how does this band steering work? Well, it's basically not, steering is actually an interesting term. We're trying to steer people. We can't tell your computer, Erica, hey, you use 5 gigahertz. We can't, okay? Because there's software in your computer that decides whether or not it's going to use 5 or 2.4. What we can do with band steering is we can try to influence. We can try to trick your computer into joining the 5 gigahertz network, okay? So one of the things that we do in our controllers on Wi-Fi is we will present the 5 gigahertz network to your computer first in hopes that it decides that it wants to grab it. And then we'll introduce the 2.4 gigahertz network second in hopes that it has already grabbed the 5 gigahertz network and it doesn't get on the slow, crummy 2.4. All right. So that's one way, that's a technique that people use in order to get people more onto 5 gigahertz. The other thing that you can do is just slow down the rate of advertising. So I'm going to advertise the 5 gigahertz network more frequently. And so in the hopes that your computer picks up on that, and I'm going to slow down the advertising of the 2.4 in hopes that your computer does not pick up on that.
Right.
Okay. So that's really important to note. We do try to steer our clients in that manner. Sometimes you can just turn 2.4 off in certain environments. Okay. Now here's the problem. The problem is that in your environment, you may have situations where you have client devices that aren't capable of 5 gigahertz. And so therefore you might be shutting them out completely if you turn off 2.4.
Right.
Nevertheless, you need to identify and figure out what your client device population looks like so you can get a handle on how severe what I just described is going to be in your environment. Okay. So, and that's another reason why, when we put our software on actual devices now, and we look at all the device drivers and we look at the adapters, we're able to get an idea as to what the capabilities of different devices are in your device population. It really helps. All right, let's keep moving along here. The second principle that we're going to talk about, now that we've talked about capacity a little bit, is we want to talk about coverage. All right, now think about this. Coverage and propagation. Okay, you've got high frequencies, you got low frequencies. These are radio waves. Okay, and these radio waves, depending upon high versus low frequency, they're either going to travel far or they're not going to travel very far at all. Sometimes in the middle of the night, you can pick up a radio station on the other side of the world.
Yeah.
It's pretty cool. And it's because those are really low frequencies and they can travel really far. Wi-Fi frequencies, there is a difference. 2.4 is the lower frequency and it can go a lot farther. 5 gigahertz is going to go, is a shorter, it's the blue wave here, and it cannot go as far.
Okay.
Now, there are certain things that you need to also know when it comes to coverage, and that is barriers to propagation. So, when you're listening to the radio and it just cuts out when you go under the viaduct under the bridge.
Yep.
By the way, what's your favorite radio station?
Here in Cleveland, it would be 96.5, which is like a pop station.
Okay, so you say here in Cleveland. Does that mean that you have like some kind of secret hideaway in some other state or something like that? Or what are you talking about?
No, I'm just saying where I'm from, where I live. Oh, okay. That's my favorite station.
Gotcha. Okay, just wanted to be sure.
Yep.
Now, what about Sirius XM satellite radio? Do you ever listen to that?
Not usually. I normally listen to the pop if I'm on Sirius though.
Okay, very good. Well, I want you to guys, everybody listening out there today, I want you to memorize this table right here because this is really important with regards to your Wi-Fi signals being able to either reach your users or not. And again, Wi-Fi is invisible. We can't see it. As a result, we sometimes don't think about these things. We don't think about the fact that an access point is over here and I'm sitting on the other side of a stairwell or an elevator shaft, and the Wi-Fi signal can't get to me, even though, as the crow flies, I'm 6 feet away from it, right? Yep. But it just can't get through to me. Because of what I just described. The ones that you really need to take note of that are really a problem are concrete and metal. Concrete, like I said, old buildings, whether it be hospitals, dormitories, You know, there's a lot of concrete, and concrete is going to absorb the radio energy, and it's not going to be able to penetrate it. All right. So again, like the stairwells and stuff like that. And then metal, like the elevator, metal shelving in a warehouse, for instance, it's going to reflect. It's going to bounce off.
Okay.
And that bouncing off, again, could prevent you on the other side of the shelving unit from getting the Wi-Fi signal that you need in order to connect or have a good experience.
Gotcha.
Okay, so that's really important. Again, take a snapshot of this right here. Know your barriers to propagation. So let's just kind of put a little bit what we talked about into practice right now. All right, so as you can see here, this is just pretend this is like a floor in an office building, and you've got one radio right here, one access point. Oh, I'm sorry, one access point with two radios, and one radio is on 5 gigahertz and the other one is on 2.4. Now, because of propagation, you have to be close to the access point in order to connect to the 5 gigahertz radio. You have to be close. So this guy's connecting just fine. This guy's kind of right on the edge. Now, Erica, do you remember why it's important to connect to 5 gigahertz instead of 2.4?
Because there's more lanes.
That's right. There's more lanes on the highway. There's more of a chance that you're going to go fast.
Yeah, exactly.
Yeah, right on. Okay, so these guys out here on the edge, they have no choice. They are not close enough to take advantage of 5 gigahertz. So they have to hop on board, get into the slow lane.
Yeah.
Right, in 2.4. Now, in order to resolve this problem, very simply, what we're going to do is we need to add more access points. We need to add more radios. And so now I've got these nice small cells all throughout, and that's a term that you might hear used, is this idea of small cells. Lots of small cells, so that when I roam from one side of the building to the other, I can kind of shake hands with the first, the second, and then the third access point nicely. Okay, so that's how you do that right there. Now, everybody in the building can take advantage of more lanes on the highway, less congested highway, 5 gigahertz. And then maybe you use 2.4 as sort of like for people out here who want to sit at the picnic table for lunch. You ever do that, Erica?
Yeah, we have one right outside of our office, and I like to sit out there.
Oh, that's wonderful.
Nice.
I'm glad to hear that.
Yeah.
So right here, this guy is sitting out there. Maybe that's you sitting out there
me?
having lunch at the picnic table.
It looks like me.
And you will still be able to take advantage of Wi-Fi.
Awesome.
Okay? We call that like a lifeline. Okay, it's 2.4 is like a lifeline network. We really don't want it to be primary. We want it to be secondary.
Right.
Okay. And the other thing I want to show you here is a little bit of what we learned putting it into practice with the channels and the congestion. So imagine this situation happening where maybe there's a company meeting, or maybe a lot of people are in a huddle or gathering for stand-up meeting or whatever it might be, all the way on the left side of the building. And then as it so happens, now everybody starts complaining. It's like, look, why is the Wi-Fi so slow when we have our meeting every day? And what they don't understand is that they're trying to jam pack all of those users into one lane on the highway, on the one channel right there, channel 149. And again, you know, a channel, a lane on the highway, you know, you can't stack cars on top of one another. They kind of go single file, one behind the other. It's the same thing in Wi-Fi, you know. And so the way to resolve this is you got to add another radio. You got to add another radio, or in this case, maybe a second radio in an access point, or you would add another access point. Okay, that's, you know, what most people would do is they would add another access point. And in that manner, half of them will grab one and half of them will grab the other. And now everybody is able to be able to spread out on the highway and go fast and have a lovely experience. Okay. And this is kind of like what it looks like, you know, in practice. So for a 2.4 network, you know, all I've got are 3 non-overlapping channels to work with. All right. And it can get a little dicey because you see how close together 1 and 1 are, and 6 and 6. Okay. They're kind of close.
Yeah.
And that's not good, because if they can hear each other, then what that means, it's like channel 6 is channel 6. There's only so much airtime on channel 6. And if you're using it on this side of the building, and I'm using it on this side of the building, and a whole bunch of other people, we're both using channel 6. That's still just the channel 6. That's the middle lane on the highway. All right. And so if all of us are crammed into channel 6, if all of us are cramming into the middle lane on the highway, that is going to get bogged down with congestion pretty darn quickly.
Yep.
So that's why we like this over here on the right, where we've got lots of channels and everybody can spread out. You see that?
Yep.
And so there's very little overlapping of like here in the corner, you got 36, channel 36 over here. It doesn't show up again until you've got channel 36 over here. So there's no risk of that co-channel interference is what we call it. Co-channel interference, where I've got two radios that are close to each other and they're actually kind of sharing the same airspace, and that could be a big problem.
Right.
Okay. Do you know what the #1 interference source is on Wi-Fi networks?
I'm gonna go with brick walls.
No, that's actually the biggest interferer of Wi-Fi is other Wi-Fi.
Oh.
Yeah.
I never even thought of that.
I know. Isn't that interesting?
Yeah.
Yeah. So let me explain with this next slide that we have right in front of us right here. So imagine, Erica, that you're listening to the radio.
Yeah.
Okay. But then somebody else comes along and they start listening to their radio. And then somebody else comes along and they turn up their radio. You can't hear your radio anymore, can you?
No.
Yeah, this is frustrating, especially when your favorite song is playing.
Oh, yeah.
Do you have a favorite song?
Probably Baby by Justin Bieber.
Okay, great. Not sure I wanted to know that, but okay. Fantastic. So here's the point. The point here is that if I'm trying to listen to the radio frequency, all right, I'm trying to listen to my radio, and there's all these other radios that are blasting, I can't hear the radio.
Yeah.
And this is what Wi-Fi looks like when you have co-channel interference. When you've got this radio on channel 6 and this radio on channel 6, now it's just a big muddled mess where I can't even hear.
That'd be so annoying.
Exactly. This is frustrating. And so one of the things that we're tempted to do is we're tempted to just turn up the volume.
Right.
If I could increase the amount of signal to overcome all of the other extraneous noise, then maybe I can have a good experience. We call this signal to noise ratio, SNR. Again, we need enough signal to overcome the noise. Now I can hear my radio, I can connect to my radio, I can use my radio, I can have a good Wi-Fi experience. However, Erica, let me ask you again. When you turn up the radio and make it loud, what do you think these other two guys or gals over here are going to think of you?
They're probably going to think I'm annoying, but then they might try to turn up their music too.
Oh my gosh, you're exactly correct. So first of all, you're being rude. I'm sorry.
Right.
But you're being rude.
Yeah.
And so you don't want to do that. You're being rude because now they're going to have a hard time hearing.
Yeah.
And what may wind up happening is that in order to overcome the noise that you're creating, they may turn up their radio.
Yep.
And now it just escalates and it turns to a big noisy mess once again. And again, when there's lots of noise, in order to cut through the noise, what happens is that we need to slow down our data rate in Wi-Fi in order to create a more robust connection. So let me give you an analogy of that one more time with the highway.
Okay.
So imagine you're trying to get up a really big hill. Okay, so there's some big hills here in Northeast Ohio and Cleveland. You're trying to get up a really steep hill. Are you going to be able to do that in 5th gear?
No.
There's no way.
No.
It's not going to happen. You're going to have to downshift to 1st gear or 2nd gear. Okay, and so you have to, it's the same thing in Wi-Fi. You can't, those high data rates, they're very sensitive to noise. And so what winds up happening is that you have to step down the negotiated data rate between you and the access point in order to create a more robust connection in order to cut through the noise. All right. And so it's the same thing. So what winds up happening in these situations is everybody slows down. And again, you would use the 7SIGNAL as an instrument in order to identify where this is taking place so that you can prevent it from happening.
Yeah.
Okay, and so this is what we're after right here. And when we move to 5 gigahertz, this is more of what we're seeing. Okay, nice and clear. Okay, I don't have to scream at you, Erica. I don't have to yell at you. I don't have to yell at you and then even upset my neighbors. I can speak to you nicely and quietly and clearly, and we're having a nice conversation, kind of like what we're having right now.
Yeah.
Okay, sound good? All right, so this is the equivalent. So when you think about 2.4, it's like going into a noisy sports bar, right? You know, it's kind of like going to the sports bar. It's Sunday afternoon. We're watching the ladies win the World Cup.
Woohoo!
I know. And everybody's cheering and everybody's yelling, and it's awesome. Okay, but it's also kind of hard to have a conversation, a private conversation with somebody even sitting across from you, right?
Definitely.
That's 2.4.
Gotcha.
What we're looking for is 5 gigahertz right here, where you and, you know, maybe your significant other, right? You kind of get off to the side and you have a nice little quiet meal with one another, and you can have a nice conversation. You don't have to yell. That's the difference between 2.4 and 5. Nice, quiet, intimate setting, restaurant, noisy, crowded, sports bar, impossible to hear. All right?
Got it.
Cool. All right, now this is a little bit of an advanced topic. We're going to talk about something called RRM. That stands for Radio Resource Management. Okay, now this is a feature that is built into your wireless LAN controller. And what this feature does is it actually fluctuates power and changes channel automatically. You can't even see it happening. It's happening automatically in an effort to avoid interference. So remember a moment ago when you were talking about how the tendency is for maybe another radio to turn their volume up? Mm-hmm. Well, that's what's happening automatically in this environment. Okay, so what happens is automatically radios will increase and decrease their power in order to try to, or in shrinking and growing the size of the cell. Mm-hmm. And then adjacent access points sometimes will react to that change by increasing or decreasing the size of their cell. When you do that, a couple of bad things can happen. One is that you can end up with a situation like this, where all of the adjacent access points end up on the same channel, channel 36, for instance. Now, again, there's only one channel 36. There's only one stretch of, that's one lane on the highway. Mm-hmm. This would be the equivalent of going from 3 lanes all the way down to 1. All right. Now, everybody in the whole office is trying to grab channel 36. It's a nightmare. It's just not going to work. All right. Now, the other thing is that when you grow and when you shrink the size of the cell, sometimes if you shrink it too much, you could be creating a coverage hole. So a person who used to get good coverage in one part of the building, because the access point shrunk the size of the cell, now I'm not getting a good signal strength anymore. I can't connect at a good data rate. Happens all the time. And again, it's hard to catch. It's hard to see. But in fact, you could be your own worst enemy if you don't tighten down these RRM settings in your system. And this is something, again, that we can catch. We can see this happening. And then we can give you recommendations with regards to how you can control your RRM so that it doesn't take advantage of you. All right?
Got it.
All right, Erica, it's time to play the game. Which would you buy?
Oh, boy. Ready? Oh, yeah, I'm so ready.
Okay, so here we go. We have 2 laptop computers, and let's pretend for a moment that they are exactly the same price. Mm-hmm. I look at the specifications for the one on the left, and I compare them to the specifications of the one on the right. Erica, which would you buy?
I mean, they both look like they have very similar specifications. Both have 4 gigabytes of memory. I'll go with the Lenovo on the right.
Okay, why is that?
It says it has an Intel Core i5.
That's right, and that is a faster processor than the one on the left, the i3.
Yeah.
Exactly, so you think you're getting a better computer, right?
Exactly.
Well, Erica, I'm sorry to report, but you would be wrong.
Oh, no.
Okay, and here's the reason why, and they don't print this on the card when you're at the store. Okay, all they do is they tell you the memory, the hard drive, and the processor, but what they're not telling you, and it's in the fine print, you got to look closely, is the wireless networking capability. Now, over here on the right, the reason why you would be wrong is because this alphabet soup right here, this BGM stuff, what this means is that this computer is not even capable of getting on the 5 gigahertz network. That would be bad.
Right.
Everything that we've just talked about in terms of 2.4 versus 5, Erica, let me ask you this. Would you want to spend all of your time on the 2.4 gigahertz network?
Not with everything you just taught me, no.
You're darn right. So what we want to do is when we're looking at this alphabet soup, we want to look for the letter A. The letter A, just like what we see over here on the left, wireless AC, okay? Now, if over here on the right, if we saw A, BGN, okay, then that would be all right because it had the letter A. That means that it's capable of going on either the 2.4 or the 5 gigahertz band. Very, very important. You better know your Wi-Fi standards. Let's talk about that now. Now, in order to get away from this alphabet soup, the Wi-Fi Alliance is actually trying to assist us. And so instead of this B, G, N, A, C, X stuff, all right, what they've done is they've come out with a much simpler system where they're using Wi-Fi 4, 5, and 6. The current standard, which is 802.11ac, the current standard that most of our computers have today, is considered Wi-Fi 5. All right. So if you don't see the letter A when you're looking at your laptop specs, look for Wi-Fi 5.
Okay.
All right. Look for Wi-Fi 5. Now, after that is a new standard that's being introduced, 802.11ax. It has an A, right? So it can't be all that bad.
Right.
That is Wi-Fi 6.
Okay.
Now let me explain to you what Wi-Fi 6 and AX is going to give us. Okay. Now, Wi-Fi 6 or 802.11ax, it is the next generation of Wi-Fi technology, but truly it's not really intended to make major increases in speed. It's actually more designed to help alleviate congestion, and it does this through like a multiplexing technology called OFDMA. And this channel multiplexing is really just a better way to share the air. All right, remember we all share the air. We're all riding on the highway together. We got to play nicely when we drive on the highway. What happens when there's an accident on the highway?
Back up.
Exactly. We all suffer. It's not fun. And so if we can share the air a little bit better, all right, so that everybody has a shot at getting, their work done, then we can alleviate congestion. Now, here's the thing. Is there any reason to go out and buy 802.11ax access points if I don't have 802.11ax clients?
No.
That's right. No. What's the point? What is the point of having an 802.11ax network if I don't have 802.11ax clients to connect to it?
Right.
And actually, not only that, but I would have to probably have 40 to 50% of my client devices on my network with 802.11ax capability in order to actually take advantage of the technology, of the multiplexing technology in order to alleviate congestion. So all I'm trying to tell you guys out there is you don't need to rush out and get all fired up and excited about 802.11ax. You probably just refreshed your network to AC in the last year or two. I would say that should hold you over for the next 4 to 5 years. Okay?
Wow.
That's my opinion.
Thank you.
All right. Ooh, okay. Erica, it's now time to play. What is this? No. Nothing to be afraid of.
Spiders.
Yes, I'm sorry about that. Let's take that off the screen right now. I didn't mean to frighten you, but here we go. You see these in the store, and a lot of people might be asking themselves, why would somebody pay $325 for one of these access point routers that I put in my home? They may be led to believe that it's just going to make their Wi-Fi experience magically faster. They would be wrong. Okay, now let me try to decipher this for you. Okay, I'm going to break this apart for you. So the first thing that I'd like you to look at here on top is I've circled AC 5400 and Triband. Let's talk about Triband. It's kind of a marketing term, quite frankly. Triband refers to the fact that this guy right here, my spider buddy here, he has 2 radios inside of him. One of them is dedicated to 5 gigahertz, and the other is what we call a dual band, which means he's capable of flipping back and forth between 2, 4, and 5, 2, 4, and 5. And so they call that Triband. All right, so that's important to note first of all. Second of all, AC 5400. Now you'll see this at the store all the time. You'll see AC 1900, AC 2100, AC 2400, AC 5400. What the heck are they referring to?
Yeah.
What they're referring to is the theoretical data rate that this unit should be able to achieve under certain conditions. What I do is I go to mcsindex.com. And when I go to mcsindex.com, I then look up this data rate, 5400. And there I kind of find it right here, 5460, 5460. So what this tells me, Erica, is that in order to achieve this data rate, I have to be on a 160 megahertz wide channel, and I have to be using 7 spatial streams at a very, very sensitive 256 QAM modulation and encoding rate. So do you remember when we were talking about 20 megahertz, 40 megahertz, 80 megahertz wide channels? Remember what I said about an 80 megahertz wide channel? That maybe it wasn't such a good idea?
Yeah, no, it wasn't.
Because basically you're taking all of your lanes and combining it to one.
Right.
All right. And if you have a lot of people, you know, basically you could run the risk of everybody crowding into that lane and causing a problem. Well, in an office environment, what do you think that would be like for if you had a 160 megahertz wide channel? That would be insane.
That'd be insane.
Absolutely.
Way too congested.
Right. I mean, you need channels.
Right.
You need the channel. So at home, this might be okay.
Right.
But absolutely not at work. It's probably a terrible, terrible idea. Now let's talk about over here, the spatial streams, 7 spatial streams. Now, that actually, when you look at this right here, you count the antennas. So this has 1, 2, 3, 4, 5, 6, 7, 8 antennas. Okay, 8 antennas. And basically this, in order to achieve the data rate that we've just talking about, it requires 7 spatial streams, or 7 of these 8 antennas. That basically, that is indicating how many simultaneous streams of data I can pass. So the next question that I have is, what does 2 by 2 with 2 streams mean? Well, 2 or 7 streams, it's 7 transmit, 7 receive, 7 spatial streams, or in this case, like most laptops, you're 2 by 2 with 2 streams. You've got 2 transmit antennas, 2 receive antennas. I can transmit, receive, or I can do double transmit, double receive, but that's how I achieve those high data rates. Okay, so to just take it a little bit further, if I have a 2 by 2 device with 2 streams, it can basically double your speed, because instead of transmitting on 1, I can now transmit on 2. And this is really important to know. Now you might be asking yourself, well, what does my device have? Am I capable of going really, really fast, or am I capable, or can I only go slow? Well, you need to know your device capabilities. And again, this is why we're, you know, we like to track this stuff. So the way that I track my device's capabilities is that I actually would open up a command prompt here on my Windows box, and I would open up a network shell with this netsh command and type WLAN show interface. And when I do, I'm going to get all sorts of juicy information here. Okay, and one of the things that I'm going to get is basically my wireless LAN adapter, the AC7265. What I do is I just copy and paste that into my Google search engine with the word specs after it. And the very first thing that appears is the Intel page indicating that this is a dual band 2 by 2 Wi-Fi adapter, 2 by 2 with 2 streams. They left off the :2. And it tells me what it's capable of. All right, so that's really important to note, because a lot of people, they think they should be able to go fast, but they can't because they have some crummy adapter that's a 1 by 1. You know, a lot of smartphones, the older ones, they're 1 by 1. And so they're not going to be able to go as fast as the newer smartphones, which are 2 by 2. They're basically doubling their ability to go fast. So it's really important to note, you got to know the capabilities. And when you know the capabilities, and then you combine that with what's going on in the environment, like do you have a lot of brick and metal? Do you have a lot of concrete? You look at your network, you got to have, you know, the right access points on the network that have the certain capabilities that match up with your device capabilities. And then of course, don't forget about your internet service provider, but it really takes all of this stuff in order to create a great Wi-Fi experience. I think it's not so simple, is it?
No, it's not.
Yeah, there's a lot to it. So you just can't, you know, point the finger at the Wi-Fi network and say, fix the Wi-Fi. Because you know what? It could be the network, it could be the environment, it could be the ISP, or it could be your client device. All right, and that's what we're trying to get to the bottom of here with our solution. All right, so we're coming down the home stretch here, and then we'll get to our questions. But here you go. All right, so there's really just a few areas where things can go wrong. This is not a mystery at all, Erica. Okay, when we have problems, when people say, hey, the Wi-Fi is terrible, it can only be one of these 4 areas. And the root cause can only be one of these 6 things. The adapters and drivers, where your device just doesn't choose the right network, or maybe it doesn't roam nicely and properly. We can detect that. We want to be able to measure what's going on in the air to see if we have interference. And do you remember what the #1 interferer of Wi-Fi is?
Other Wi-Fi.
Bingo, that's exactly right. Now there's also Bluetooth, which is another biggie, but I would say Wi-Fi is #1. And then when it comes to access points, they can get overloaded and congested. All right, and this is where we need to add more access points. Sometimes access points get frozen or stuck. All right, so we need to be able to detect that. All right, we've got some nice steps for remediation down here as well. And then of course it could be something on the network. And this is where, you know, obviously you need to run down a few things, and you probably have other systems in order to check these things out. But when somebody says, hey, you know, fix the Wi-Fi, it's terrible, remember what we learned today, okay? It doesn't necessarily have to be the Wi-Fi network. Generally, when we go to the Wi-Fi network, everything looks fine. All right, it could be your client device. It could be that you've got a slow, crummy, junky wireless LAN adapter in your computer that's not even capable of going fast.
I never even thought about that either.
I know.
Your own device being the issue.
Exactly, and so that's what we're trying to educate people with all the time here. So with the time that we have left, let's take a look at some of our questions here to see what we have here. Well, the question that we have is basically, will we share this deck? And this recording will be made available. Okay, so once we're done, we will be able to make this link available so that you can download it off the internet. And the other question is with regards to you know, whether or not I like cars. And I do like cars. You know, so what kind of car do you drive, Erica?
I drive a Jeep Compass.
Jeep Compass, and how's that working out for you?
It's awesome.
Good.
Drives very smooth.
Now, what about the car that you had before that?
I had a Honda Civic.
Okay, now what about the difference? Do you like the Jeep Compass better, or do you like the Honda Civic better?
I like the Jeep better. I feel like it drives smoother.
Oh, good. Glad to hear that. Okay, now I drive a Buick Regal GS. Now the GS is the Grand Sport.
Oh.
And it also has 20-inch wheels.
Oh.
And it
sounds fancy.
It's not fancy at all, actually. It is a Buick, so it's not that fancy. But it does go fast.
Oh.
All right. Well, here's another question that just came in, and keep them coming for the next couple of minutes, if you will. And the question is with regards to how 7SIGNAL diagnoses Wi-Fi issues. And so, so what we have are kind of like these basic training webinars, these courses, where we actually dive into the 7SIGNAL system and we walk around the system, and we actually will show you this is how Wi-Fi, or this is how 7SIGNAL detects a congestion issue. This is how 7SIGNAL detects an interference issue. And then, you know, we learn how to take care of it together. So that is another series that we can get you hooked up into. We'll follow up with you, and we'll make sure that you actually get plugged into one of those webinars. Okay? Well, if there aren't any other questions, what we'll do is we'll come to an end. Erica, I want to thank you very much for being my partner today. I really enjoyed working with you, and thank you very much for your input.
Yeah, Eric, thanks. I learn so much from you every time I hear these presentations from you, so thank you.
Oh, you're very welcome, and I hope everybody out there has a great day, and keep coming to these webinars.
Yes.
You know, we want to educate you and empower you with knowledge to go out and have the best Wi-Fi experience possible.
Yes.
So thank you once again, and signing off.
Thank you, everyone.